We're starting a unit on slope. As you can tell, I've got a couple questions up here that I'm sure you guys will have. And my favorite, and I'm sure it's every teacher's favorite, is will I ever use this? I can answer that question for you right now. Yes, you will. What does it have to do with math? Well, it has everything to do with math. Everything. There's all kinds of algebraic equations in it. You'll be adding and subtracting. You'll be graphing. Everything to do with math. Okay? Is it used in the real world? Yes, it is. When you're walking up the steps, there's a slope. When you're walking down the stairs, there's a slope. When you're standing on level ground, you have zero slope. It's everywhere. What does slope look like? Well, we'll look at it right now. Okay. You now have a picture in front of you that tells you the 4 types of slope that there are. You've got positive, negative, zero, and undefined. Okay? Just like a book, when you read left to right. Just like when you solve a math problem, you add or subtract or anything. You solve from left to right. You are going to read this coordinate plane left to right as well. So you're going to start in this lower left hand. Let me change the color here. Lower left hand corner. And if you start down here and you increase, you can obviously see it's going to be a positive slope. Well, if you start up here where the blue line is, and you're reading from left to right, you start at the top and go down, you're decreasing, so it's going to be a negative slope. If it just stays the same all the way through, has no change at all, it's going to be a zero slope. And a lot of times you guys, when in class, you'll refer to it as no slope. It means the same thing, but the mathematical term that I'll say, and you'll see on tests and quizzes, is that it's a zero slope. And an undefined slope, as you see here, is a vertical line. Is just straight up and down. Okay? And I want to go back and talk about these positive and negative slopes. Think about going up the stairs. If you go up the stairs, if you was to go up a set of stairs, if you start here at the bottom and you go up, you're increasing. Same thing with negative. You start here at the top and you go down, you're decreasing. Okay? If you're standing on level ground, if you're not going up, if you're walking on level ground, you're not going up a hill or down a hill, it's zero slope. If you can remember this in your head that way, it'd be a lot easier. Okay. So now, let's talk about the definition of slope. It is just simply the steepness of a line on a coordinate plane. And right over here, let me change my color again. Right over here, there is a sorry excuse for a arrow. Is a coordinate plane, and it shows you that you've got the first quadrant, second quadrant, third, and fourth. And if you notice, it does not go from left to right because it is going in counterclockwise. Now, this is this axis right here. Your vertical axis is your y-axis, and your horizontal axis is your x-axis. You need to know this because whenever you go to graph slope, you'll be graphing it on a coordinate plane. Okay? Whenever you see slope in algebraic equations, it's going to be represented by the letter M. Okay? M, which is slope, is graphed on a coordinate plane with rise over run. That is simply, and as you notice my arrow right here, the blue one, and now my pink one, it is simply the change in y is rise over the change in x, which is run. And we'll do some examples of those in just a second. All right, for calculating slope, you have let me get this right here. Okay, you've got a formula to plug it into. That is y2 minus y1 divided by x2 minus x1. And if you notice right over here, I already have 2 ordered pairs labeled for you. So, in a normal ordered pair, x always comes first, then you have y. So that's why I've got them labeled over here. This x1, y1, x2, y2. If you're given 2 ordered pairs, the first ordered pair you come to is going to be your x1, y1, and the second one you come to is going to be your x2, y2. All right, so if you just simply plug it into this equation, your y2 is 4, minus your y1 is 6 divided by 0, and your x1 is negative 3. And always keep those minus signs that they're in the middle. But now if you notice, you've got a negative and a negative beside each other. This parentheses is telling you to multiply this negative and negative. And everybody should know negative times a negative is what? Yes, I feel like Dora the Explorer. But yes, guys, you were right. Negative and a negative is a positive. So you would change that. 4 minus 6 is a negative 2. 0 plus 3 is 3. So your slope, and notice that I represented it as m, equals a negative 2/3. And if you was to go back and look at your 4 types of slope, you would see this has a negative number. So this is a negative slope. Very simple. Do not make this harder than it is, guys. Very, very simple. Okay? All right. Now, finding slope by graphing 2 points on a coordinate plane. This, you're going to graph it. You're not going to use that calculating. You're not going to use your formula like we did on the slide before. You're going to just graph it on the coordinate plane here. So, it says determine the slope of the line that contains the 2 points 5, 3, and 5, 1. It doesn't matter which one you graph first because we're graphing it here. But if you want to, I always just graph the first one. 5, 3, you're going to start here in the, let me choose a different color, darker color. Okay, so right here, starting here in the origin. 5, you're going to go over to your right 5. 1, 2, 3, 4, 5. Up 3. 1, 2, 3. Where they meet, you put a point. Then you're going to go back over, because you're going to start back to, you're going to go back over to your origin. Over 5. 1, 2, 3, 4, 5. Up 1. Where they meet, you put a point. And we're going to draw a line through those 2 points. What type of slope is that, guys? Did I hear an undefined? I bet I did. And you are correct. Pretty simple. This is even more simple than calculating it. I know you guys will do just fine. Alright guys, on this slide, I want you guys to pause it and work these 2 problems out using the formula y2 minus y1 divided by x2 minus x1. Label your points when you write down your question. Here's x1, y1, x2, y2. All this does is it just helps you so that you don't get it mixed up. And you can just substitute it straight in and just solve it. Go ahead and solve both of those problems. Pause it, solve it, and then I'll be back and we'll work through the example, make sure that you did it right. Okay, welcome back. We are going to go ahead and solve it. Here's your number 1. You've got y2, which is 16, minus y1 is 8, divided by 9 minus 20. 16 minus 8 is 8. 9 minus 20 is a negative 11. And that is your final answer. You notice that you've got a negative in front of the fraction, so that would be a negative slope. Hopefully you guys got that right. All right, number 2. Number 2, you've got, like I said, label them, x1, y1, x2, y2. Your y2 is 3, your y1 is 3. Your x2 is 20 minus your x1 is 19. 3 minus 3 is 0 over 20 minus 19, 1. You guys know that anything divided by 0 is going to give you 0. But what I want you to notice here is that the 0 is in the numerator. Numerator of the fraction. And what this means is that you have a 0 slope. If you was to graph these 2 ordered pairs in a coordinate plane, you would see that it would end up being a horizontal line, which would be a 0 slope. If the 0 would have been in the denominator, that would have been an undefined. Can't fit it on there. Undefined slope. Just keep that in mind. Make sure you write that down in your notes, okay? All right, guys. Last slide. I'm going to give you some examples. On this one, I'm going to give you a set of ordered pairs, well, 2 sets of ordered pairs in each example, and I want you to put it on a quick coordinate plane. It doesn't have to be perfect, just a quick coordinate plane, and I want you to tell me what type of slope it is, of the 4 types of slope that you know about. So if you've got, the first ordered pair is 3, 2, and the second ordered pair is 3, 6. I'll give you a second here. Pause the video, and you'll work it out and then tell me what type of slope it is. Okay, you're back. Welcome back. Here is a quick coordinate plane. We're going to go over 3, 1, 2, 3, up 2. Where they meet, you put a point. Again, for this one, you've got, this is your x2, y2. Go over 3, up 6. We already went up 2, 3, 4, 5, 6. Where they meet, you put a point. We have a straight up and down line. What type of slope is that? It should have been an undefined slope. If you got that right, good job. Let's do one more. All right, the second order pair is going to be, second pair of order pairs is 5, 1 and 3, 7. Okay, I'll give you a second to do that. Go ahead and pause it. You'll figure it out. All right, welcome back. Now our quick graph is you're going to go over 5. Remember, you always start from the origin. Over to the right 5. 1, 2, 3, 4, 5. Up 1, put a point. Over 3, you're going to go. Well, you're going to start with your second order pair. Start back at the order pair, or I'm sorry, origin. Go over 3. 1, 2, 3. Up 7. 1, 2, 3, 4, 5, 6, 7. Put a point. Connect those 2 lines. What type of slope is that? If you was to start from left to right, if you read it starting here and you're going to go down, it's a decrease, so that is a negative slope. Easy as pie. Hopefully everybody did awesome with this. Tomorrow, expect to have, make sure that you've taken good notes tonight. If you haven't taken good notes, start this over. Take good notes because you're going to need it tomorrow for the activity. Okay? Get some rest. Have a good breakfast in the morning. I'll see you guys tomorrow.